Hello, everyone. Thanks for attending this session. I'm Sina, an IT security researcher and consultant, and in this session, I'm going to talk about a data leak. I guess you all have seen an image like this in the past.
When your doctor needed to see inside your body, they prescribed you a medical imaging examination. Something like X-ray, MRI, CT scan, stuff like that. And the result was a printed image like this. This is a DICOM image. And DICOM is the standard that defines how these images should be digitally structured and stored. Also, it defines a network protocol that says how these images can be transferred in a network. This has been very useful protocol and a standard for past 3 decades. It helped us curing many diseases, saved a lot of lives. But recently, it became a liability for healthcare sector. There has been some research, news for past years that there is a big data leakage going on in the health sector, and the root cause was reported to be the DICOM protocol. So we were interested to know, okay, what's actually leaked? What's the extent of this leakage? What is out there? And if after these years, research, report, news, if it's actually better now in 2023. Sadly, the answer is no, and it's actually increasing globally. Right now, it's more than 59 million of records of people, patients. Many of us sitting in this room is accessible on the internet because of this protocol. The reason, the root cause is that we started modernizing the healthcare like other industries without upgrading the legacy protocol of the industry, in this case, DICOM. Many hospitals started moving their DICOM infrastructure to the cloud because it's cheaper, it's easier, it's faster, it's good. So they did the shift, and they used the legacy protocol DICOM without sufficient security, without even being aware of the security risk of using such protocol and information on the internet. So it has started this leakage. And also because it has started a shift towards more digitalization, and nowadays you don't see those images printed anymore, it also pressured small businesses to catch up with this trend. Otherwise, they would be out of business soon. So they also started exposing their DICOM to the internet with whatever they had to just catch up with this trend and stay in business. Of course, the smaller businesses usually don't have enough resources, budget to maintain a complex and secure network. So it's actually amplifying this leakage. When we studied this protocol this year, we found more than 3,800 DICOM servers accessible on the internet, and more than 73% of them are either from the cloud, like big hospitals that move to the cloud, or more than 1,100 of them are exposed just via DSL connection, the DSL that you have at home even. And these are the small imaging centers that they have a very simple IT infrastructure with a DSL connection. They just expose their DICOM server to the internet just to catch up with this trend and can digitally share the result with other doctors, but of course without sufficient security and protection. So we were also interested to know, okay, what data is actually leaked and what's possible to do with this protocol and data. So we studied the whole DICOM protocol and to find all the attack vectors that I'm going to show you later in this presentation. Then we scanned the whole internet for more than 6 months from different countries, different providers, different services to find all the DICOM servers accessible on the internet. Then we enumerated them to see how many records they are exposing, what is on those records, what information, and how many. Then we analyzed the gathering, because many of those servers are, of course, honeypots. Some of them are staging and demo environments of the vendors. It's interesting to know that this protocol and technology is also used for animals. So many of the records on the internet actually are for cats and dogs. And many of the records are exposed via universities or research centers that they just share anonymized data with other research centers. We removed all of them, and what was left at the end was more than 16 million personal identifiable information, including name, address, phone number, gender, in some cases, social security numbers, and more than 43 million health records, including the actual result of the examination, place, time, and date of the examination, name of the doctor, name of the operator, all of that. And this is what makes this leakage different with a classic one. For example, if your credit card information is leaked, you just call your bank, they revoke it, you get a new one. But if your personal information, your social security number, your name, address, everything is leaked, you cannot easily change it. And it's going to stay valid for almost a lifetime. The same for health information. If it's leaked, some people have long-lasting disease. And if the information is leaked, it can be used for many harmful purposes, blackmailing, identity thief, social engineering, etc. This information is coming from more than 111 countries, on top of which we have United States with 18 million records, then India, South Africa, Iran, and Brazil. But it's also interesting to know that if a server is hosted in one country, mainly for United States, that doesn't mean all the information stored there belongs to United States citizen, which is actually another result of cloudification. Because many hospitals started using big providers like AWS, GCP, Azure, and they don't have services in all countries. So for instance, if a hospital in Asia wanted to move to the cloud, they just used GCP, started an instance in the United States, and storing their data there, which is actually against of many data protection policies, because such sensitive information should not leave the country and be stored like that in a server somewhere else. But the question is why DICOM has all this information, patient information, address, phone number, all of that. To know about it, we need to know a little bit more about how DICOM works, and we need to know more about a very important component in medical imaging, which is called PACS, Picture Archiving and Communication System. You can consider it as a storage that stores DICOM images, and it speaks different protocols. It speaks DICOM protocol, so modalities can upload images, viewers can search and retrieve images. It speaks healthcare protocols like HL7, so you can integrate it with the information system of a hospital for patient management, for billing, and so on. And in some cases, it has a web interface for doctors as a patient portal or for administration tasks. Very sensitive, important component that should be isolated inside the hospital network, well secured, well protected, but it's on the internet right now, even via a normal DSL connection. DICOM images are stored as an object in a PACS in multiple layers. The first layer of a DICOM image is actual image, the pixels that the device took during the examination. And because an examination can have more than one image as the result, for example, you can have 5 MRI images as a result of an examination, images always come as a series. You can consider series as a folder that contains one or more than one DICOM image of the same type. For example, it could be one X-ray DICOM image. It could be 10 CT scan images. Each series belongs to a study. And a study is the examination that your doctor prescribed. For example, an MRI examination is a study. And in this layer of a DICOM object, we have date, place, time of the examination, comments from doctors, doctor name, and sometimes even the result of the diagnosis of that examination. Ultimately, each study belongs to a patient, and in this level, we have the personal information: address, phone number, name, gender, even sometimes allergies, because it's important for some examinations. Very detailed personal information. And information in each layer are stored as elements via 4 attributes. The first is tag, that defines, okay, what this element is. Then we have value representative that says what type of information this element holds. We have length and the actual field, the actual value of the field. These are 4 main layers of each DICOM object. If you have one DICOM object, it comes at least with these 4 layers and all the information. This is the reason why if one file is leaked, all the information comes with that. And the reason of the leakage is the network protocol of DICOM, which is a TCP/IP protocol. It's a client-server architecture. And as the first step, client requests a new association to establish a session. Server may authorize the request based on the application entity title, which is actually the name of the client. It's a string up to 16 character, or IP address. If the association is accepted, then the client can send the actual messages. And in this layer, we have DICOM message service elements, which are the actual DICOM requests and responses, and they have 2 main categories. One is query and retrieve, that a client can use for searching for data or retrieving data. And this could cause data leakage because hacker can access data with that. And the second category is a store, CS-store service that a client can use to upload new images to a server, to a PAC system. And this could enable hackers to tamper with the existing information. On top of all of that, we have implementation issue because DICOM is a very complex and huge protocol and a structure. So in many implementation, you can find vulnerabilities like database injection, buffer overflow, etc. We will see later. But since we have authorization on the first ever request, then we should be good, because if it's authorized, there's an access control, nothing can go wrong. But unfortunately, many vendors do not even implement access control support. And the rest that support, the clients, the hospital, do not use it because they're not aware of the risk and how to use it. More than 2,900 of servers we found they do not have access control. It's just on the internet, respond to whoever sent the request. That's it. The rest that they had authorization and access control, for more than 750 of them, we could bypass it with a simple dictionary attack because they use default information. It's like admin in a web application that you install and everybody knows the credential. In this case, when a vendor produces a new product, a DICOM product, they need to publish a document called conformance statement. And the document says how this product is compatible with the DICOM standard. And in one of the sections, section 4411, they need to list all the default AETs that come with this product. So we built a database of those default AETs by scrapping all these documents because all vendors publish it on the internet. We also collected some common ones, in total around 250, something like that. And with a simple dictionary attack, we could bypass more than 750 servers authorization. Only less than 1% of the servers on the internet have a proper authorization, either based on the source IP address or a random AET that we couldn't find. After this, when someone finds one of those servers without authorization or with a weak authorization and they can bypass it, the first step would be to collect data via cfind, cget, or cmove. I'm not going to elaborate on very deep technical details because there are many research and articles about them on the internet. You can easily find many good articles. One of the best I could find is from Roni Zaharia. He has a blog and explains DICOM in very deep details and also explains how PACS usually internally works because he's a PACS engineer himself. But in short, cfind enables the client to search for data. It's like just searching and see what you have in your database. cget and cmove enables the client to retrieve, kind of download the whole DICOM image. And the difference between cmove and cget is that in cmove, the client can say where these images should be sent. It's not like a download, it's like forwarding them somewhere else. And all these three services accept wildcard search. So you can just say where the patient name equals a star, everything, and get everything back easily. The important thing to know here is that more than 30% of the servers on the internet right now support these services, cfind, cget, cmove, without authorization or with weak authorization. 1,159 servers, that means a hacker just needs to find them on the internet, know the IP address, port number, and know how to use a command line tool. That's it. They are pretty much set to access sensitive information. And you can see that just 30% of the servers on the internet leaking more than 59 million records. So imagine if a hospital decides today to move their infrastructure to the cloud without security, we would have one more server on the internet exposing data, but that means hundreds or maybe thousands of more records on the internet. This is a significant change that one server can have. But after having this information, it's not all, it's not about the leakage, because we also have CStore. And because of the nature of CStore and how it works, we figured out that it allows attacker to tamper with data. So CStore simply allows a device, a modality, to upload the result of a new examination. When a server receives this request, it adds a new row to the database with patient ID, study, series, and instance ID. And it also stores the actual image, the pixel data, on a storage and link it to the database record. Each image has a number, an instance number, that says how it should be sorted in a series. It's usually a sequential number starting from 1, so it's 1, 2, 3, 5, 4. But the problem is that a standard, the DICOM standard, does not say what number it should be. What's the range? How you need to define it. Is it an integer? Is it a float? Could it be negative? Could it be 0? Does it end anywhere? Or it could be infinite. There is nothing about it. It just says it must be a number. And in all the implementation, it's a float, the variable that holds it. So it could be anything. You have infinite possibilities. There is one more problem, which is DICOM standard does not say how you can close a series. It remains open forever. So if I did an examination 3 years ago and a series created for that examination, it is still open, and up to today, you can add a new image to that. It never closes. What happens if a hacker can access the data? They can learn about patient, study, series, and images. They can have all the information. They can use that information to craft arbitrary images and sends it back to the server. And server accepts new images with any ID that hacker wants. So later, when a legit user like a doctor or whoever wants to access that data and retrieve it, what happens on the server side, on the PACS, it's a simple select query on the database to find all the records for this study or for this patient, and then find the images on their storage and sends them back. That means the doctor, after this tampering attack, will see a tampered series of data Because there is no limitation on how many images a series can have, actually hackers can destroy a series effectively by injecting thousands or millions of images into a series. And DICOM does not have any service to delete images. And even in medical processes, you cannot just delete result of an examination because this data is sensitive. It should go through a manual process. So if you have now 1,000 random images in a series, there is no standard, there is no process defined or anything to remove them. So you actually lost the series of data. Or, because it's possible to place the new images wherever you want in a series, they can even introduce false sign of illnesses into a result of an examination. For example, if you have a CT scan of a brain, they can inject images into that series to inject a signs of a tumor, for example, in that brain. If they know how a tumor looks in a brain, of course. Just to see how it works together, let's look at a short demo. So this is how usually a doctor can see a DICOM image. They have a viewer, it connects to the remote server. They can look for patients with a wildcard, so they can all the patients and their studies. In this case, you can see there is a study of mine. A CT scan of the brain happened on 26th of September 2023. So my doctor can just import it to the viewer and sees an image like this. And all the images in this series can be displayed like a video together. But from the hacker's perspective, of course, the first thing is to find the servers exposing DICOM, and all the scanners like Nmap, they support it on 3 port numbers 104, 4242, and 11112. Then easily, there are many clients that they can use. The one I used is a Python script, and in this case, I just asked for all the patients on that server. Like what my doctor could see, I can see all the patients, including myself with the name and the patient ID. Then I can use the same tool, but this time I use the GET request, and GET downloads all the file on my computer. It usually takes time because these files are very big. But once we have all the files downloaded, we have them like this. Each of these DICOM objects have all the information about patient, study, all of that. Every single of them stores all the layers. And then I can just use a local browser to visualize them. When I insert all these images, we can see the first layer, which is patient. Then we have our study, the series, image. And in each image, we have our elements that holds all sorts of the information. Finally, visualization like what the doctor could see. Once I have all this information, I can just generate new images based on the information I got. I just wrote a simple Python code to extract the information and generate the new images I want. I just generated around 1,000 new images because I just wanted to destroy the series I have. And then I use CSTOR to send back all the images I crafted to the same series. It uploads all the data you can see on the Wireshark that they're going one by one. Takes a couple of minutes. And afterwards, when the doctor wants to see exactly the same series, looking for my records, you can see it's exactly the same CT scan of the brain, 26th of September 2023. But I'm pretty much sure my doctor can see much better now what's actually happening in my brain. This could be like that, which should not actually happen in the real world. They can effectively destroy a series like this, or even more smarter, injecting something that shows I'm sick, for example. On top of all of that, before removing, it's important to know which is Very important and serious problem because more than 39 million of the records on the internet are vulnerable to this tampering attack. Because thousands of the server on the internet that provides these query and retrieve services, they also support a store. So a hacker can chain all of them together and tamper more than 39 million of records, which is a big danger, I assume. On top of all of that, implementation issues doesn't make the situation any better. One of the most common ones is a skill injection. I found at least one skill injection in any implementation on the internet. Even as simple as in the AET authorization, like the old days when there was a login form and you could use something like admin or 1=1 in the username. You can do the same thing, but in the AET authorization of PAX system and DICOM servers. It works in many cases. Or even a little bit more advanced, you can retrieve all the information about users, patient, whatever is there. What we saw so far is not very something new in the field of IT security. Access control, encryption, isolation, SQL injection. Why we still have it in 2023 in the healthcare for such a critical infrastructure? The problem is actually lack of governance. Because DICOM standard protocol says we have introduced the security measures, access control, all of that are on the standard. They are not just mandatory. We cannot make it mandatory because it's going to break many products and systems, so it's up to the vendor to implement them. Vendors say, okay, it's not mandatory, why we should implement them? It's a lot of effort, we are not going to gain anything. If we don't have them, we don't lose anything, so we are all good. Of course, I think around 10% of the vendors globally have implemented security features, but it's not sufficient because the number is not big enough. And when it comes to the customers, like hospitals, they don't have many options. They cannot really find all the options secure to build their infrastructure. And it's not really feasible, for example, to ship a big MRI device, let's say from United States down to the Europe, because it has access control or TLS. They will never, ever do that. And when it comes to the audit, like ISO, GDPR, HIPAA, the auditors also know the situation. So everybody's pointing the finger to the other side. Nobody's doing anything. And this snowball is going down, getting bigger, impacting all of us because it's healthcare and we all need it. We cannot avoid it. But this number, 59 million, is increasing every day because more examinations are happening, new vendors coming, new hospitals going to the cloud. And nothing is stopping it right now. To fix it, at the core, what we need is an effective governance that should come from the standard bodies, from the DICOM standard organization and auditors. Many industries like telecommunication have experienced that for many reasons. It's the same for healthcare and medical imaging. They first need to separate the new version with the current version with the mandatory security measures. Then communicate it with the vendors and tell them after a deadline, for example, 2026, 2025, we are not going to license your products if it's still the old version of the DICOM. So they have enough time to adopt the changes, they know the rule, and they start implementing the new version. Also, they should communicate it with other organizations like ISO and make sure they have it under checklist and under agenda after the deadline. So if a hospital or a vendor still use the old version of DICOM, they are not going to certify them. They are not going to give them the certification. It takes time. It takes a lot of effort. And it's on all of us, not just an organization. And until it happens, if hopefully it happens, there are some mitigations that hospital can do, for example. The first priority for hospitals should be not to expose your DICOM server to the internet. There is no single reason why such a sensitive component and information should be accessible on the internet without any security control. So first and the most important thing for hospital, make sure it's not on the internet. If you have your DICOM servers hosted remotely, cloud or somewhere else, establish a secure tunnel like IPsec between the remote host and your internal network. Regularly scan your internet-facing assets for DICOM ports. Make sure it's not exposed, because it happens. Maybe someone changed something on the network and all of a sudden it's exposed. Make sure you have an eye on your internet-facing assets, and if DICOM is accidentally there, mitigate it as soon as possible. Second priority, make sure inside your network you have a dedicated segment only for DICOM. Nobody else has access to that. Make sure only your modalities, MRI, CT scan devices, can access that segment with DICOM protocol, no one else. For users, use DICOM Web. DICOM Web is a standard coming from the same standard organization. It offers a REST API instead of the old binary protocol. And many modern DICOM viewers and browsers support this protocol, so you can easily use it on your network and secure it with a WAF. You can have TLS on that. You can mitigate and protect issues like SQL injection via a WAF simply. It helps a lot. And the third priority should be access control. If your products support AET authorization, enable them. If not, use your network firewall to only access, give access to the modalities IP addresses, whitelist them only. And if you need to, and integrate it with your IAM for user access to make sure only doctors and whoever should have access has access to that. And in case you need to give remote access to users outside of your facility, your hospital, only do it via DICOM Web, because you never have a modality outside of your network that needs to upload something. So only DICOM Web should be exposed, only via a firewall. And with access control. Implement rate limiting on that, because inside your network, for internal network, you can, maybe it's not really feasible to have a rate limiting for DICOM, because you have your surgery room, you have your emergency room. Maybe it could cause a fatal error if you have a rate limiting. But if a doctor needs to access your DICOM server outside of your facility, usually it's not for emergency cases. So a delay is very not likely to cause an error. Also, you can apply regional IP whitelisting, for example, allow the access only from your country, not the whole internet. There might be some corner cases where someone's from another country or somewhere needs to access that data, but they can contact you. You can make an exception and give them the data. It's still better than have it open to the internet. And besides of the medical institution, if you're a vendor producing DICOM products, implement AET authorization. It's simple to implement. It's well documented. And also implement the extended negotiation of user identity. It's an extension to this protocol. It's supplement 99. It's also documented by the standard organization. It allows many advanced access control mechanisms that clients and customers can use. To mitigate the tampering attack, do not allow a new image to be added to an existing series after threshold, like 1 hour or 2 hours, because that examination is done, the result is already uploaded, and you shouldn't accept a new image. It's usually abnormality. Even if you might need it, you can make it conditional that a user manually should approve a new image to be added to an existing series after threshold. And also perform regular security tests. The best case for DICOM implementation is fuzzing, because it gives you a good coverage and can undercover many different vulnerabilities for you. If you want to go for deeper security penetration tests, of course, is the case. And you should mitigate the vulnerabilities you get on the report, not just doing the test. That's also an important point for that. For the country certs, you can scan the range of IP address of your country frequently, regularly, like every month. If you see any DICOM, inform the owner of that IP address, help them to mitigate it. We informed country certs of multiple countries after our studies. Unfortunately, we didn't get any response from them, but hopefully they're doing something about it. After all, DICOM is just an example of a legacy protocol that causes problem in an industry. And I believe as security researchers, we should investigate such as protocols, help the industries to fix them. And because of these legacy protocol DICOM, now more than 59 million of records on the internet are accessible to everyone, every single of you. And to fix it at the core, we need an effective governance by the standard bodies or DICOM standard organization that hopefully starts soon. If you have any question, we have a couple of minutes left. Otherwise, thank you so much for your attention. Thank you. Any questions? I think you should use the mic.
Yeah, thanks a lot for the great presentation. I'm now confident that your brain works similar than mine. Just one question. You noticed you detected SQL injections or similar. Did you attempt to approach the service owners or vendors
Yes.
in this situation?
So the whole study, we have reported that to certs, vendors, different organizations, standard organization, but unfortunately no reply.
No reply at all.
No.
Okay, thank you.
No. Great. If you still have any question or you would like to have a chat, you can just grab me outside because the time is over. Thank you so much.